This is a very different kind of function. We're going to use it a few times in our class. We'll use it here. We will definitely use it in probability. I forget whether it comes up in stats again. It's called a factorial. So I would name this n factorial. The definition is said to be a recursive definition. It's recursive because the new values for n factorial depend on the old values for n factorial, as you'll see in just a moment. Remember from algebra that domain for a function means the values you're allowed to put into the function. For the factorial function, the domain is whole numbers. So for this, I'm not allowed to use negatives, fractions, or decimals, which I'm sure some of you think is a good thing. We're going to start by defining it at 0. 0 factorial is 1. Now that's going to sound very strange. When we get to probability, we'll have an explanation for why it has to be 1. It needs to be 1. 1 factorial is also 1. And again, when we get to probability and we delve into this a little deeper, it'll make sense why it has to be 1. Now we get to the meat of the matter. 2 factorial is 2 times 1, which gives me 2. 3 factorial is going to be 3 times 2 times 1, which gives me 6. Now please notice, 2 times 1, that was 2 factorial. So 3 factorial is actually 3 times the answer to 2 factorial. Here we go for 4. 4 is 4 times 3 times 2 times 1. 3 times 2 times 1 is 3 factorial, so 4 factorial is 4 times 3 factorial. That will give me 24. Okay, so 5 factorial. This is the last time I'm going to do this. That 4 times 3 times 2 times 1, all of that is 4 factorial. So to find 5 factorial, I take 5 times the answer to 4 factorial. 5 times 24 gives me 120. So 5 factorial is 120. The way we write this is that n factorial is equal to n times n minus 1 factorial.